Assalamualaikum warahmatullahi wabarakatuh. My name is Sofian bin Mataki. My matrix number is B1124410202. Our topic is about to explain the steam turbines. First thing first, what is the steam turbine? The steam turbine is a generator that main power conversion of a component of a power plant. The function of the steam turbine generator is to convert the thermal energy of the steam from steam generator into the electrical energy. Those parts are two separate components that are provided. The steam turbine is to convert the thermal energy into the rotating mechanical energy, and the generator is to convert the mechanical energy into the electrical energy. The thermal energy of the steam converted to mechanical energy by expanding the steam through the turbine. Next, these are the characteristic water in the process of evaporation. The highly purified water is heated in a boiler or steam generator using a heat source like a burning fuel, nuclear reaction, and converted into the high pressure, high temperature, and superheated steam. On the cooling section, the separated steam of the cooling water is circulated through the tubes inside the condenser to absorb the latent heat released by the condensing steam. Lastly, in the condensation, after passing through and expanding in the turbine, the low pressure exhaust steam enters a condenser where it is converted back into the liquid water.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Haizam bin Syafuddin, and today I will discuss about how water is used in steam turbine. So first of all, we should make sure the water that we use are clean condition. So we treatment and preparation. So next, the water that we after treatment, we steam it, and then steam can measure the turbine spin by a pressure. So after the turbine spinning, the electrical energy will generate. So after that, we can reuse the water by condensation. So the steam should transfer to water back, and then the water was recycling. So and then we can reuse the water that we convert to steam for another process.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Fadli bin Muhammad Fadli. My matrix number is B1124108182, and I am from BLK section 12. So today I want to present about topic 2, water use in steam turbine, ethical management in water. On this slide, I explaining how industry use a large amount of water. First, underwater intake. Industry pump big volume of water from river or groundwater. When water is taken faster than it can naturally refill, the water level drop. This reduce water availability for nearby community. Next, great imbalance. There are three imbalance: access, benefit, and environmental impact. Access, industry get more water, community get less. Benefit, industry use the water for profit, but community face the negative impact. Environmental impact, lower river or groundwater level cause stress to the environment. Lastly, community and agriculture. When industry take too much water, while produce less water, village face weaker water pressure, and farmer reserve less irrigation water. This show how one sector affect many other. For the second slide, I talk about the ethical issue in water management. The key issue are fairness, right versus need, and pollution risk. Industry should not take water that community depends on, and access to clean water is a basic human right. Poor pollution control can also harm river and public health. For the real case, I use Sungai Selama pollution. Industry wastewater cause treatment plant to shut down several times, leaving millions in Klang Valley without water. This case show ethical failures such as negligence, weak monitoring, and community harms. That's all for me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. Nama saya Muzaki bin Zakaria. Nombor bateri P1124 175. So hari ini saya akan tentang slide saya yang bertajuk Reducing Water Consumption in Steam Turbine, Optimization, Operation Efficiency and Environment Stewardship, Innovative Solution for Water Conservation. Point first is a dry cooling system. Utilize air as the cooling medium, significantly reduce water dependency. Second point is water recycling. Implementing process to treat and arouse cooling water within the facility. 3 point is treats and wastewater use, leveraging reclaimed water resources, reduce reliance on fresh potable water. The last point is closed loop cooling, minimizing water loss through evaporation and a blow down in the sealed system. Technical deep dive. Second slide is a technical deep dive. How does the technologies conserve water? Point first is dry cooling system. Instead of the evaporation water, dry cooling system is a large fan to calculate ambient air over fine turbine, transferring heat direct to the atmosphere. This eliminates water consumption for cooling, especially critical in arid regions. Point number 2 is water recycle and use. Advisor, filtration and purification technology, reverse osmosis, ultrafiltration, treat spent cooling water, condenser, and process wastewater to quality suitable for reintroduction in the this reduce the need for any water input. Next, third point is utilizing trace wastewater. Partnering with a municipal wastewater treatment plant, also the use of their effluent for industrial cooling purpose. This provides as a sustainable water source will reduce their discharge burden on a local ecosystem. And the last point is a closed loop cooling system. Those systems isolate the cooling fluid from the outside environment, theoretically cut down on evaporative loss and the need for a continuous blow down. Chemical treatment maintain water quality for those extending its lifespan within the loops. Next slide is ethical and sustainable water management. Point number one is environmental responsibility. Minimizing freshwater, abstract protect local ecosystem and biodiversity. Point number two is community impact. Reduce competition for source water resources with local community and agriculture. Point number three is economic benefit. Low operation cost, those reduce water procurement and distress fee. And the last point is long-term sustainability. And sources continue operation in a region facing increasing water stress. Thank you.
Disadvantage of steam turbines. The primary disadvantage of using a steam turbine, particularly in large-scale power generation, steam from its system complexity, high infrastructure costs, slow startup, inherent thermal limitations, and maintenance besides operational issues. The first part is high initial cost and complexity. Steam turbine power plants are financially demanding due to the high complexity and scale of their required components, such as the boiler, condenser, and pumps, leading to massive initial capital investment and significant long-term maintenance expense. Okay. The second part is slow startup and response time. Warming up massive boiler and turbines takes hours to prevent thermal stress damage. This low response makes them poor for peaking power and ideal for continuous baseload use. The third part is thermal and water requirements. Efficiency demands condensing steam at the lowest possible temperature or pressure in high vacuum. This requires massive cooling water use, which is the main environmental issue due to high intake and heat discharge. The last part is maintenance and operational issues. In essence, power plant equipment must withstand the intense combination of high heat and pressure while resisting internal damage from erosive water flow and corrosive impurity, demanding top-tier materials and meticulous maintenance to avoid breakdown.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Firdaus Dayat bin Muhammad Zaidi and my metric number is B1124101888. Today I will present conclusion and the policy recommendation and standard. For the conclusion, the operation of steam turbine power plant requires significant volume of the water of steam production, cooling, conditioning, while this support energy generation. Also, the correct environmental, social, and ethical implication, particularly in the water scarce or densely population region. Environmental impact assessment (EIA) play a critical role in identifying potential risks of the water resource ecosystem and community well-being before project approval. Effective water management guidelines ensure industrial water withdrawal, treatment, and discharge are sustainable and do not compromise local water security. Strong community engagement is equally essential, ensuring that local population who depends on the same water source are respected, informed, and included in decision making. When these three frameworks work together, programs can operate responsible and reduce conflict and protect the natural and social environment. Policy recommendation and standard. First, environmental impact assessment (EIA). Water resource impact evaluation. Conduct comprehensive hydrological study before project approval. And second, include the essential water available from water recharge rate and river flow pattern. Require cumulative impact assessment, not only develop project analysis. And be moderatory alternative assessment, compare wet cooling, dry cooling, hydro cooling technologies. Evaluate water saving technologies. For example, air condensation condenser, and require stipulation if a water intensive method is selected. See water quality and pollution control standard. Enforce parameter for influent discharge BOD, COD, TSS, and temperature. Require zero discharge system or closed loop cycle where possible. Risk contingent planning require emergency response plans for operation event, emergency spill preventive system for chemical and wastewater. Two, water management guideline is sustainable water intake, set maximum withdrawal limit based on environmental flow requirement, prioritize on potable water source treatment, wastewater, seawater for cooling, monitor water withdrawal in the real time accessible to government agency. Efficiency compensation vendor water event cooling system require periodic water use audit and efficiency benchmark. C, wastewater treatment standard comply with national influent discharge regulation, include the DOE Malaysia standard AB system advanced treatment, national reverse osmosis treatment system. D, transparent monitoring, online water quantity sensor and intake discharge point, public access to water quality report to build transparency. 3. Community engagement. A. Early and efficiency practical. Begin cooperation at the planning stage, not after construction has started. Engage affected group and nearby village farmer and fishermen, NGO. B. Clearing community transparency. Provide a non-technical summary of EIA of the public. Discuss water withdrawal amount, influence test result, risk assessment. C. Grievance redress mechanism. Stable and formal community complaint system with graduate response time. D. Benefit sharing measures, support local water infrastructure, include the well pipes, backup water tank. Provide C. SR program address water security, community education, and environmental. E. Continuous engagement, protecting the overall meeting. And for summary, to ensure ethical, safe, and sustainable operation of the steam turbine plant, EIA must through assess water supply pollution risk and alternative water management guidelines must inform responsible intake, efficient use the and safe discharge. Community engagement must guarantee transparency, practically, and fair treatment. Together, this framework protect environment, on whole, community right, and ensure that industry development is socially responsible. That's all from me. Thank you.